This is a tutorial on the astrolabe. The astrolabe was intended to be used in ancient times for both observation and computation. For the astronomical usage in this tutorial, let's get rid of not needed parts. Also on the back side. To get better results, sometimes an eccentric calendar was used. A first example for the usage is to calculate the sunrise time. Let's assume we have 1st of May. On the back, rotate the so-called alidade to this date. Look on the ecliptic longitude ring and note 41 degrees. Note also a value of -3 minutes for the equation of time on the alidade. Flip to the front of the astrolabe. Rotate the so-called redi, such that the ecliptic longitude ring with 41 degrees reaches the horizon. Rotate the rule, so that it reaches the 41 degrees. Finally read the time, which is 4 hours and 42 minutes. To get the local solar time, you have to add the value of the equation of time that you have noted from the back. Let's assume we are in Frankfurt, Germany, which has a geographic longitude of 8.7 degrees east. Central European time meridian is at 15 degrees east. This means we are 6.3 degrees west of the CET meridian. 360 degrees equals 24 hours. Therefore 15 degrees equals 1 hour, that are 60 minutes. So 6.3 degrees equals about 25 minutes. Taking into account also the daylight saving time of 60 minutes, we have a sunrise time of 6 hours 4 minutes CEST. In addition, you can determine that the azimuth is about -115 degrees. So, the direction of sunrise is 65 degrees counting from north to the east. In the next example, let's measure the altitude of the star Rigel. Then determine the according time and the sidereal time. For this, grab the throne and look up to the sky. Point to the star Rigel with the sights of the alidade. Read the altitude of 12 degrees. And note it down. Let's assume we have 4th of November. Rotate the alidade to this date. Note 222 degrees for the ecliptic longitude. At this date, there is an equation of time of about -16 minutes. Note it down. Flip to the front side. Find Rigel on the redi. Rotate the redi such that Rigel has an altitude of 12 degrees above the horizon. Rotate the rule to the ecliptic longitude of 222 degrees. Read a solar time of 22 hours 32 minutes. Taking into account the equation of time, we get a local solar time of 22 hours 16 minutes. Using the same geographical longitude as before, we get a time of 22 hours 41 minutes CET when Rigel has an altitude of 12 degrees above the horizon. To get the sidereal time, rotate the rule to an ecliptic longitude of 0 degrees. This is the vernal equinox, or also called first point of Aries. Finally, read the sidereal time of 1 hour 16 minutes. Now let's have a detailed look to the different parts of the astrolabe. The limb containing the time information. In our case, the solar time. And the sidereal time. The direction ring with the cardinal points. The climate plate, It is designed for certain latitudes only. It contains the horizon, and a grid for azimuth and altitude. In the center, there is the zenith. The grid represents the stereographic projection of the local coordinate system. The ring with the ecliptic longitudes. The redi, pointing to several bright stars. The rule, needed to point to the different scales, the grid, and shows the declination of stars. The right ascension of the stars. The zodiac. It was used in earlier times instead of the ecliptic longitude. The twilight zones showing the civil, nautical, and astronomical twilights. The tropics and the celestial pole. The unequal hours. They were used centuries ago when time was described as the fraction of the time from sunrise to sunset that had passed. Some modern astrolabes are using transparent foils with many stars, instead of a redi with some bright stars. Finally, let's have a look to the details on the back. The inner circle with the ecliptic longitude, and the outer circle for measuring the altitude of the sun, star or object. The zodiac. Same description like for the front. The calendar. In this case, an eccentric one, to cope with the elliptic orbit of the Earth, which leads to a better accuracy of the readings on the astrolabe. The equation of time. In modern astrolabes it is used to determine the correction of the solar time to the local solar time. The alidade. Like for the rule, it can be rotated and is used with various scales. On top of it, it contains the scales for the equation of time and unequal hours. In addition, there are two sights through which you can see a star or object to determine its altitude. In case of the measurement of the sun's altitude, don't look through them but use them as projection on, for example, a card. Otherwise you can harm your eyes. The sine scale. This can be used for calculations when dealing with circles. The unequal hours. Same description like for the front. The shadow square. It was used to determine the height of objects, or the distance to objects.